thanks very much for watching this clip. This is a clip that Brooke Gibbons and I have prepared, just trying to highlight the uses of this web app that Brooke's made called CheckEM, which is about checking event measure outputs or fish annotation outputs that you might want to upload to Global Archive and share in syntheses of BRUV data or any other kind of video stereo-based image annotation data. Now, what we're going to show you in a minute is actually a live demonstration we did with an Australian BRUV working group and also a draft selection of people for Global Archive Steering Committee. To find out more information about Global Archive, just follow the links in the documents describing Global Archive that was sent around with this video link. But also you can look on CheckEM itself and look through the user guide of how to use CheckEM to check and validate your fish annotation data. So we'll let you go to the clip now and have a look at that, because it's kind of like a live demo. It's kind of a bit more exciting with some actual real research users like marine park managers and other scientists in the demo, listening and giving feedback and asking questions. And then we'll come back in a second and talk more about the use of this app and the future development of it. Thanks. So as we said in the introduction, in the Australian fish BRUV synthesis work we did, we learned a lot of things. We learned a lot of different ways that people do things wrong. And as part of that, Brooke and many of us were involved in coming up with a variety of scripts like in R to sort of pick up some of these errors so that we could go back to the researchers and tell them where they needed to fix things. But what we've actually done is what Brooke's done is take all these scripts and actually put them into a web app, which makes it really relatively easy to check the data and so for anybody to check the data. So what I think I should do is I should go onto Global Archive and show you how someone like Kath Sampson could use this to make sure that someone like Tim Longwa has done a good job. Okay, so for example, up on Global Archive here now, there is some campaigns in the southwest of Australia, southwest stereo BRUVs. So these is campaigns here in the southwest of the country. We can have a quick look on the map and see where they are. These campaigns were collected for a NESP project, benchmarking, fish benthic assemblages in and outside this national park zone in the southwest corner Australian Marine Park. Now, but what we want to do is we want to check that Tim did a good job. Okay. Now, what we're proposing in some of the new workflows we're going to talk through in the next meeting is that CheckEM, this app that Brooke's made, will be used before the data goes into Global Archive, but you can also use it for data that's actually sitting in Global Archive. So, for example, here's the campaign with all the data that's from this deployment. Now, if we downloaded, for example, the metadata, the points, the 3D points, and the lengths data, what we can then do is we can then upload this data to CheckEM. So hang on, that'll be the points. That'll be the, which is 3D points, which is lengths. Who remembers which one I did next? Where is it? Oh, here we go. So they're just uploading in the background now. So what this is doing is it's uploading the point data. So those tables we saw on Global Archive, those are the data tables that come out of Event Measure when you ask it to give you a data table output. So it's all the actual real core annotation data. So that's the one thing Global Archive does, is it actually archives the actual annotation data. So when we want to work with people doing machine learning or automation stuff, we've got all the real annotation data, not the counts, not the max ends, not the summarized length. That data is no use to anybody really in QA/QC terms. But so we've got the length data as well. Upload that. Oh my God, Bennett. And then sorry about that. And then the 3D points data as well. So basically, for people that don't know, the 3D points are where typically you can't actually measure a fish, but you can still get a range estimate on it in Event Measure Land. But the length is all the calculated lengths of every fish, and the points is actually, that's the max N annotation or the counting annotation that you would do to before you go and collect the length data. But so it's really good to have all that data there. Now, what this does, okay, is it shows us a quick view of the metadata. We can have a quick look at it to make sure Tim's done a good job at putting in the right things. But the important things that we can then do is then check the metadata. Where are these samples? You wouldn't believe how many samples we received for the Australian Bruv synthesis that were on the land and potentially weren't in the right place. We just quickly check here. Oh, yep, that looks like about right. That looks where Tim was supposed to go. That looks pretty good. 274 metadata samples, 19 samples without points. Now that we can actually download a quick list of those. These samples don't have any annotation data. So likely those samples failed. So they weren't able to do any annotations at those samples. But here there's no annotation data that doesn't have metadata. That's good. But because believe you me, people submitted annotation data without metadata to the Australian synthesis. Any questions? Nope. Brooke made all this. Plot of the most abundant species. Just makes a quick stacked abundance plot. Corey Wakefield gave me the idea for this plot, but just quickly show you the most abundant species: Western king wrasse, football sweep, Western Mary wrasse, and you can just change a few things to. Do you want to see less species or more species and see what's going on, just to get a quick view. Now this is useful just to give you a rough idea of, you might see some really strange looking species that shouldn't be there, or some species that's not identified. But what this also does is it links to the Australian life history sheet that Brooke maintained for the Australian synthesis. And there's a couple of things that does. The synonyms, the names are changing. The fish names are often changing. So what this has done is it's actually updated a couple of fish names. I bet you it's updated Pagurus auratus to Chrysophorus auratus, pink snapper, and it's probably done another one as well. Other important thing it does is a bit of a red flag. There's 19 fish here which have never been observed on Bruv data or in the existing records in this region. And so that'd be a good idea to check those. So this basically is like a list that I can just download and have a look at. Now, a lot of these are going to be actually species that weren't able to be observed, or species that actually maybe are tropical species that have shown up here, which is quite expected. But this is part of the QA/QC you can do. Anything else I should talk about, Brooke, in here?
Well, yeah, then you can choose the drop downs and they're ordered in the same order as the above plot, so by abundance, and then just have a look at them spatially and by status or site.
So we can see where all the pink snapper are, just in a little bubble plot, and then just a quick plot by status of where the pink snapper are. Now these status zones come from the shape files. Is that right, Brooke?
Mm-hmm.
Yeah, so Brooke's made it so the metadata queries shape files to then tell you which zones they're in, which, believe you me, is more reliable than people who tell you what zone it's in the metadata. It's better to query a shape file.
So this is getting very close towards Nev's state of the environment reporting that he's been dreaming of for the last 15 to 20 years.
Trying to get there.
No, it's close. It's getting close. It's not far off, because you could actually pull together, I imagine, data sets. You could form a project, say, for example, all of the 2020 data in certain years, and then you could do the same for other years and start comparing across years. It's not that, it's not that big a jump. Yep. It's a big jump technically, but it's not that big a jump.
So we've got that in the development plan, start using this to comparing data sets, because one of the things that AI people or the machine learning people want to do is compare their machine learning ones to actual human annotated. So Brooke's got an idea of how we're going to do that with this as well, which is going to be really cool. But then also for the synthesizing, the summarizing multiple data sets together for a synthesis product, we can also start to do this with this too. But here, I'll go a bit more quicker, but length. So a couple of things it will do for length is it's again going to tell us species that haven't been seen before, any lengths that are smaller than you would expect based off existing records, or lengths that are bigger than you'd expect. So here's Western king wrasse. There's a few that are a little bit smaller than the 15% of their minimum size or fish base. There's quite a few that are quite a bit bigger. So for Western king wrasse, there's so many of them, I wouldn't worry about it too much, but I might end up worrying about this for certain target species, such as, hang on, can I just write Auratus?
Yeah.
Yeah, so say common target species, I really want to make sure these guys are falling within their known range of sizes. Otherwise, it's going to blow out any biomass data I do, or blow out any of my greater than legal size metrics I might want to make out of this data. And all the range, you can do QA/QC on the range of the annotations, because a lot of people standardize the range to different what's his names, and we can put in RMS too, Ewan. We haven't got RMS in here, but we could put in RMS, so we can see precision. So there's 3 of them are out of more than 8 meters away. We might trim them out, and then you can download it in the summarized version you want, which is the max n, your length data, and the mass data, and you can tell it to remove things that haven't been seen before, dodgy species, change the range, do all that kind of stuff. And yeah, we got big plans for this. Right, so that was our fun live demo. So as we've talked about, this CheckEM app can be used for checking and validating where species are occurring and the size range of the species you're seeing on video annotation data. Some of the other things we've also got in this CheckEM app you'll see is comparing count data to length data, which is really important to see that you're actually getting a good picture of the length distribution of the fish you're identifying in the video. So for example, what we'd hope in the standard operating procedure for, oh, we've got Jürgen. Hi, Jürgen. Anyway, what we'd hope for in the standard operating procedure of, say, a BRUV analysis is that the number of fish you count, you're also going to try and get the same number of length measurements for that matching number of fish. And that's what this sort of one-to-one red line shows on here. Is that a bit small, Brooke? I can make it. Oh, that doesn't really help. Does it resize? No. Oh, here we go. Anyway, have a go. You can see, and then there's also, if there's particular species you're worried about, like multi-dens was a very common species in this campaign. We can actually just zoom in and have a quick look at multi-dens and see that we have this many max ends, this many lengths. So we don't quite have the number of lengths to match our count data. So it suggests that you can go and check out those videos again and try and improve the number of length measurements to try and actually get all those counts of the length data. And the other thing this is doing, Brooke, I'm pretty sure this is right, is it's adding in any 3D points, which are where you can't actually get a length data, but you can still get at least 1 point on the fish because it might be at a funny angle or like half in and out the frame. And so this length max n is actually a compound of the length measurements and the 3D points, which you might want to use to know that you can standardize, say, the sample unit area of your sample out to a certain range. What's going on here? I've made everything smaller. Okay, so so we have 43. What's that 43 for, Brooke?
That's how for each, the number of times that you don't have a match. So
okay, the number of times.
Have more or less.
So it's 43. 43 species don't have a kind of a good match between length and the count and the length data numbers. Okay. It's important stuff though. Now, the other nice check here is so what the CheckEM has now done is it's taken the length data that was made and it's used the length rate relationships in the life history data that's driving CheckEM to calculate the actual mass of each species. Now, this is really useful to check the mass because if people want to use mass, biomass as a metric from stereo video data, people are very keen on that idea, but you can get really funny patterns coming out from a few strange length measures or some species that might not actually really have good representative length rate relationships. Some of those length rate relationships out there are a bit funny, and so you can just quickly see here the skew of the data. Now, actually, it's driven a lot by this very common target species, Pristomortes multidens. There's an awful lot of them, and they're quite big, but it's quite common to see a few sharks coming up here as high biomass contributors across the study. And then, of course, Brooks also put in here, so often you might want to do it without sharks because many of the sharks are going to really skew the whole thing. So you want to see it with and without the sharks, which is really, really handy. And then also we can see here a spatial plot of, where do we go? Where the data is and the biomass distribution for particular species. And you just want to have a bit of a check on that and see what. So I wonder where the tiger sharks are. Where are the tiger sharks? Oh, see, there's only a couple, but because they're so big, they end up being a very large contribution to the total biomass. Yeah, there's only a couple of tigers. They have a huge contribution of biomass. I personally would like to consider whether or not you want to use them, depending on the question. Now, as we got to in the demo, you can then, of course, download this data. Now, we uploaded point annotation data, but now we can download the summarized data as either the count data, the length data, or the mass data with the matching metadata records on it as well. We have to put in a project name and a campaign ID before we download, I think, Brooke?
Yeah.
Yep. And we can choose to keep species names that have been updated, corrected for their synonyms, but we can also remove species that haven't been seen in this area before. So if there's a whole lot of dodgy looking species in there, or species where you're not really sure about the identification, we can remove those as well, which is an important thing to keep track of. But at least the idea of this workflow is that the raw annotations are preserved. So if you ever change your mind about how you're dealing with these rare species and these species that might not have been observed before, you can go back to the raw annotations and summarize it in a different way. Of course, we can change the range estimates or range limit to the sample. Get rid of any that are smaller or larger than their fish-based recorded maximums. Anything else important to say on downloading, Brooke?
No, I think that's everything.
Okay, cool, awesome. And so if you have a good look through the user guide, that provides a whole lot of information about how to use CheckEM. And also, what you'll note is currently CheckEM is made for using for the Australian marine regions. That's the life history data that drives it. But there's no reason why we can't start to collaborate with other people. And we're talking to people in South Africa at the moment about extending CheckEM to be able to use global or international life history data sets. So at the moment, if you're from the UK and you upload your event measure annotation into CheckEM, it'll say none of these species have ever been seen here before because none of those species will be in the life history database used behind it. But it's is it a hard thing, Brooke, for us to add more species into the life history database?
No.
Because we can share a template and people can add their species and we just append it to the template and then it will work. Pretty much.
Yeah. It's harder to change it to different regions though.
Yeah. Anyway, we've also provided a bit here for a place for feedback. So please send us some feedback on this app. Let us know what you think about it. And also, of course, we've got our acknowledgements from our funding. A lot of the work we're doing now in CheckEM has been funding through the Australian Research Data Commons, through our Australian Data Partnerships program. And that's going to be recognised in the new version of CheckEM that we're working on at the moment. That's about it. Thanks very much.